This portion of Dream Car Garage is brought to you by XV Motorsports, engineering modern supercars from classic muscle cars.
Now that we've returned from Multimatic, where we did the torsion testing on the Cuda chassis, we measured 9,800 pounds per degree of twist in the chassis. We elected to add some bars here and here to help increase the stiffness on the front end. We've done some selective stitch welding on the seams, and we've also fabricated these pieces that are going to get welded in to close up the openings in the inner fender aprons. Additional to that, we've also fabricated a new lower rad support. The original was not boxed, it was just an open section. And we've boxed in the upper rad support. All of this should really help contribute to increasing the stiffness in the chassis, reducing the deflection under quartering. Underneath the car, we fabricated frame connectors, joining the front and rear subframes together. These exactly match the floor pan, and they're welded in from front to back, really increasing the torsional stiffness inside the main cabin area. With all the things that we had to do on this project, it meant that we had to work on both chassis and engine development at the same time. When it came to engine packages for this project, John had some very specific ideas.
Our requirements were for a modern engine package, one that was lightweight and reliable. I wanted EFI, I wanted distributorless ignition, and as we looked around, the current modern Hemis that Chrysler has to offer, we thought were a perfect fit. It was a package that we knew we could make a lot of horsepower with. Our objectives were basically to have engines that were between 500 to 1,000 horsepower. We wanted these mated to 5- and 6-speed transmissions. So truly a modern package in terms of making power.
One of the challenges with developing the 5.7 and 6.1 Hemi engines in power ranges from 500 to 1,000 horsepower is that there were no parts. These engines are so new that there are not yet parts developed for these higher power levels, so we had to redo everything from scratch. First thing we did was we engineered a connecting rod, and we had it manufactured for us. Heavy duty, ARP bolt, billet steel, 4340, good for about 1,000 to 1,200 horsepower. We also had to develop pistons, forged pistons, move the ringland down for nitrous, supercharged, and turbo applications, gas ported, lots of modifications to handle the increased power. We went to ARP. We had to have them make studs for us, both head studs and main studs, because the stock fasteners aren't considered durable past more than about 500 horsepower. We also had to develop billet camshafts and profiles for naturally aspirated, supercharged, and turbocharged programs. With all of these components, it finally allowed us to go and put some engines together, develop some packages, and dyno test them. We are using the AEM fuel injection system to run both the 5.7 and 6.1 Hemi engines, both on the dyno and in the car. Testing on the engine dyno lets us dial in the ignition and fuel maps for maximum horsepower and torque at each RPM and load point. Later on, we'll finalize the calibration utilizing in-car testing for such things as cold start and drivability. These engine packages will be used in the XV Motorsports turnkey cars and offered as crate motor packages for muscle car and hot rod builders. Next week, we continue development on the Mopars, focusing on the suspension, turning these classic muscle cars into modern supercars.